They are some of the most powerful explosions of energy in the universe. Supernovae, stellar events so bright and energetic that they can outshine entire galaxies for brief periods. To even begin to understand these cosmic spectacles, we first have to appreciate the stars that give rise to them. When we look at the Sun, we are reminded of the immense energy it radiates across our solar system. Its light warms our planets, powers weather systems, and sustains life on Earth. But the Sun, impressive as it is just a small star in the grand scheme of the universe. Out there, beyond our familiar solar system, lie stars so enormous and powerful that they make our Sun seem almost insignificant. One of the most famous among them is Betelgeuse, a red supergiant star that dominates its corner of the Milky Way. Betelgeuse is a star that defies easy description. Its immense diameter, irregular pulsations, and unpredictable behavior have made it a source of fascination, and sometimes concern, for astronomers. Recently, observations from the James Webb Space Telescope have revealed new details about this cosmic giant, sparking excitement and questions about its future. Could it be approaching a catastrophic end? If you look up at the night sky during winter months in the northern hemisphere, you can actually spot Betelgeuse with your naked eye. It marks the upper left corner of Orion, glowing with a distinct reddish-orange hue. Its brightness is striking, making it one of the most easily recognized stars. Yet, Betelgeuse is far from steady. While it can shine brilliantly on some nights, at other times it appears noticeably dimmer. This variability has puzzled skywatchers for centuries. This flickering isn't an optical illusion. Betelgeuse lies roughly 640 light-years from Earth, meaning the light we see tonight actually left the star over 6 centuries ago. Its changing brightness is caused by its status as a pulsating red supergiant. These stars expand and contract in a complex rhythm, sometimes over a few months, sometimes spanning several years. As Betelgeuse breathes in and out, its surface grows brighter or dimmer. Its apparent magnitude, a measure of brightness as seen from Earth, can swing from 0.0 at its peak to as faint as 1.6, like it did during the unusual dimming in February 2021. Betelgeuse's reddish hue is the result of a relatively cool surface temperature of around 3,500 Kelvin, cooler than the Sun's 5,500 Kelvin. This lower temperature means it emits less light per square meter, yet its colossal size, roughly 20 times the mass of the Sun and a radius over 1,000 times larger, ensures it still dominates the night sky. This star has captivated humanity for millennia. Ancient astronomers like Ptolemy catalogued its position, and its Arabic name roughly translates to, the armpit of Orion. While early observers could only appreciate its brightness and color, modern technology has allowed astronomers to probe Betelgeuse in unprecedented detail. The Hubble Space Telescope has captured images of Betelgeuse's surface, revealing turbulent patterns of gas and dust. Observatories like ALMA in Chile have detected massive plumes of gas being ejected into space. These phenomena are the result of pulsations and convection, where hot gas rises and cooler gas sinks, creating waves across the star's atmosphere. Adding to its drama, Betelgeuse is speckled with enormous star spots, regions of intense magnetic activity. Some of these spots are thousands of times stronger than the Sun's magnetic field, and they appear cooler than the surrounding areas, dimming the star's light in localized regions. Some of these magnetic patches are so massive they could fit multiple Earths across them. As the star rotates, these spots move in and out of view, further contributing to its variable brightness. Betelgeuse isn't unique in being a red supergiant. Antares in the Scorpius constellation and Mu Cephei, the Garnet Star, are also cosmic giants with similar properties. Antares is about 700 times the Sun's radius, while Mu Cephei stretches over 1,650 times the Sun's radius. While each star has its own personality, different brightness, mass, and behavior, They all share the common fate of massive stars. A violent end as a supernova. Supernovae are among the most awe-inspiring and simultaneously terrifying events in the universe. These colossal explosions mark the death of massive stars, and the energy they release is almost unimaginable. In the case of a Type II supernova, which is the fate awaiting Betelgeuse, the process begins when the star exhausts the nuclear fuel at its core. Without the outward pressure generated by fusion to counteract gravity, the core collapses inward, compressing matter to extreme densities in a matter of seconds. This collapse is not the end, but the prelude to one of the most energetic events the universe can produce. As the core implodes, the surrounding layers of the star rebound outward violently, creating a titanic explosion that can shine billions of times brighter than the sun. For a brief period, the supernova can outshine an entire galaxy, visible even across intergalactic distances. This brilliance, however, is fleeting, lasting only weeks to months, but the impact on the surrounding space is profound and long-lasting. During this cataclysm, the extreme heat and pressure in the collapsing star forge elements heavier than iron. Elements like nickel, gold, platinum, and uranium are produced in a process called nucleosynthesis, and they are hurled into space at thousands of kilometers per second. These elements are not merely cosmic debris, they are the fundamental building blocks of planets, moons, and even life itself. In a very real sense, every atom of gold in your jewelry, or the iron in your blood, was once inside a star like Betelgeuse. The supernova essentially seeds the galaxy, creating material for the next generation of stars, planetary systems, and potentially living organisms. The shock wave generated by the explosion travels through surrounding interstellar space, compressing clouds of gas and dust. This compression can trigger the collapse of these clouds, sparking the formation of new stars and planets. In this way, the death of one star gives birth to many others, a cosmic cycle of destruction and creation. Yet the power of these events is not without danger. Supernovae emit intense radiation, including gamma rays and X-rays, capable of ionizing gases, disrupting atmospheres, and potentially damaging the DNA of living organisms on nearby planets. The expanding blast wave, traveling at thousands of kilometers per second, can physically reshape interstellar regions, sweeping away or compressing material in its path. While Betelgeuse is far enough from Earth, over 640 light-years away, to pose no immediate threat, its eventual explosion serves as a sobering reminder of the violent forces at work in the universe. Scientists continue to study its pulsations, dimming events, and magnetic activity to understand not only when it might explode but also how supernovae evolve and impact their surroundings. Some astronomers speculate that Betelgeuse could go supernova in just a few thousand years, a blink of an eye in cosmic terms, while others predict tens of thousands of years. In either case, we are witnessing a star in the twilight of its life, one whose end will reshape its corner of the galaxy. When you look at Betelgeuse in the night sky, glowing in Orion's shoulder, you are witnessing more than a distant star. You are observing a cosmic powerhouse in its final stages, a star that, in its death, will create some of the heaviest elements in the universe, illuminate the sky across light years, and influence the formation of new celestial objects. Betelgeuse embodies the duality of the cosmos, breathtaking beauty intertwined with immense, potentially destructive energy. Its light tells a story of creation and destruction, reminding us that the universe is alive with motion, mystery, and raw power. Even now, its flickering light and turbulent surface hint at the approaching end. And when the moment comes, the death of Betelgeuse will be not just an astronomical event, but a vivid illustration of the cosmic cycle, how stars live, die, and give rise to new worlds. In that sense, Betelgeuse is both a warning and a promise, a reminder of the universe's volatility, and of its endless capacity to create, transform, and inspire.